All right, this is 8.6, last lesson, inverse of matrices. So what is the inverse of a matrix? Well, first off, we need to talk about the identity matrices. And so the n by n identity matrix denoted by n sub n, or I sub n, sorry, just I where there is no possibility of confusion, is the n times n matrix consisting of ones on the main diagonal and zeros everywhere else. The main diagonal consists of those entries in the first row, first column, second row, second column, and so on, so down. Okay, so if you look at the example, right, the diagonal ones, okay, that's just what it looks like. So then the inverse of a matrix, say you have A. If I take matrix A times its inverse, which is A to the negative first power, and we talked about inverse before whenever we did functions, we wrote it as F to the negative first. Okay. So anything to the negative first power is the inverse. If I multiply those, I get the identity matrix. So there's three ways to find the inverse. We can use Gaussian elimination, we can use a shortcut formula, or we can use the graphing calculator. So find the inverse of the matrix using all three strategies. The first strategy is Gaussian elimination. So when you do Gaussian elimination, you want to make it to where you have the main diagonals as 1. So what we do here, I would say this is probably the strategy you won't use that much unless you really like it. You put your matrix over here, and then you put your identity matrix on the other side. So our goal is to get 1s where the 2s are, and then 0s where the -1 and -3 are. So we're trying to like kind of flip-flop the matrix. So first thing I want to do is I want to make this a 1. So I'm going to divide the top row by 2. So when I do that, I get 1, -3 halves, 1 half, and 0. Okay, so then what I like to do is I'm going to get this to a 0. So you work your way down. So I'm going to take row 1 plus row 2. So we get 1, -3 halves, 1 half, 0, because row 1's not going to change. Now we're going to add these. I'm going to get 0, 1 half, 1 half, and 1. All right. So then my next goal is to make this a 1. So I'm going to take 2 times row 2. And then my last goal is to make this a 0. So I'm going to take row 2 times 3 halves plus row 1.
I didn't get that.
So whenever you do that, you're going to get 1, 0, 1. I'm sorry, 0, 1. Again, your bottom row is not going to change. So I take 3 halves times 1, which is 3 halves, plus 1 half is 4 halves, which is 2. And then 3 halves times 2 is 3. So I would get 3 plus 0, which is 3. So then this right side, now that we have flip-flopped the identity matrix, so look at what we started with, now it's on the left side. The right side is your answer, so the inverse matrix of A is that 2 by 2. All right. Strategy 2 is the shortcut, and it works for a 2 by 2. So first thing I need to do is I need to find the determinant, which is what we did last class. So I'm going to take 2 times 2 minus -3 times -1. So the determinant of A is equal to 4 minus 3, which is equal to 1. So then you take 1 over your determinant times, now here's the tricky part. The top left and the bottom right are going to switch spots. And then the top right and bottom left are going to switch signs of the original matrix. So the 2 and the 2 are going to switch spots. And then in the -3 and the -1, I switch their signs. So they become both positive. And then you multiply by your determinant on the bottom side of 1. So it's 1 divided by 1 here because our determinant was 1. So when I multiply, I get 2, 1, 3, 2. And if you notice, that's what we got whenever we did Gaussian elimination as well. And then I'm sure if you type it into your calculator, I'm going to attach a video that shows you how to do that. You're going to get the same answer. Okay? So then it says find the inverse of each matrix if possible. 2 by 2s are pretty easy because all you have to do is find the determinant and go from there. So I would get 12 minus 12, which would be 0. Okay, if you have 0, remember you're putting it under 1. Well, you can't divide by 0, so the inverse on this one is not possible because I cannot divide 1 by 0. B, again, you would type into your calculator. And I attached the video, so this is what I would do in my calculator. If you get a 3 by 3, it's just easier to do it in the calculator. This one ends up being not possible because you get an error if you type it incorrectly. And then C, again, type it into your calculator. The inverse would be negative 1, 0, 0, 6 sevenths, 1 seventh, negative 4 sevenths, 1 seventh. And so whenever you get fractions on your calculator, they actually show up as decimals, but you can hit math fraction to convert it, and the video shows that as well. So that is how you find the inverse of a matrix. We use our calculator pretty much for the whole thing instead of trying to solve it whenever it's a 3 by 3. So now we can use it to solve a linear system. You can write a matrix equation. So again, this is just like the coefficients. But notice I put times x, y is going to equal my answers. So it's the same way over here, but you got to put it in order. So x, y, z. And you do the same thing on this one. So I'm just combining all my x's and my y's and moving them to one side. And then going from there. All right. So like on this one, I would have added x, which gave me negative 2x, which is why I put negative 2 first. Okay, this one I subtracted 4. Okay, also notice the second one, just as an example, doesn't have any x's, so I put 0 in the x spot, in the x column. So we've done that before. That's whenever you do augmented matrices. So a matrix equation can use to solve it, because what you're going to do is you're going to find the inverse, and then you're going to multiply it by the answers, essentially. All right, so I'll do one with all the work. But again, you can type a lot of this into your calculator. So let's make our matrix equation. So I'm going to find the determinant to start with of the original left side of our coefficient matrix. So take 4 times 7 minus negative 5 times negative 3. So take 28 minus 15, which is 13. So then I would do 1 over that times, now I'm going to switch A and D and then change the signs of B and C. And so my inverse matrix is going to be 7 over 13, 5 over 13, 3 over 13, 4 over 13. So then once you find your inverse matrix, and again, you could type all that into your calculator to find the inverse matrix, you're going to multiply it by the answer matrix. And we call that the solutions matrix. So I would take this row times this column, and then this row times this column. And so whenever you type that in, you could do that on your calculator as well. We did that whenever we did algebra matrices. You're going to get 21 over 13 plus 5 over 13 to get my first number. And then you would get 9 over 13 plus 4 over 13 to get the second number. So when I add those, I get 26 over 13, which is 2, and then 13 over 13, which is 1. So it's 2 and 1, which means x is equal to 2, y is equal to 1. So that is how we use an inverse matrix to solve an equation. Now again, you can use any of the old methods, honestly, to solve a system. You can use Cramer's rule, you can use Gaussian elimination, or you can use the inverse method. It's not going to quiz you on that. It just wants to make sure you can solve a system using any method. And a lot of this is done on your calculator, so for like the virtual kids, if you're struggling with this, I would rewatch those videos. You can come in for extra help or get on a Google Meet, and I can kind of show you how to use your calculator accordingly. Okay? If you have any questions, please let me know. Your homework's going to be 10.5, which is the last one, and then we'll start testing. Have a good day, guys.